Okay, PCH, let's go over one more modeling problem as a class to really stamp the process for us. So it tells us that the temperature in Central Park can be modeled periodically over a 12-month period. Let's stop right there. What is this sentence telling us about our function? Yeah, it literally tells us that the temperature is modeled periodically over 12 months. Once 12 months have gone by, the cycle begins to repeat itself. And so it's telling us that the period of this function is 12. All right, it says Central Park reaches its hottest temperature of 102 degrees in July. It's going to come with more practice in reading these problems, but the thing that really should stand out to you here is the fact that it tells you the hottest temperature is 102 degrees. You cannot get hotter than the hottest temperature. That is an extreme. And so that's telling us that our maximum temperature is going to be 102 degrees and it's going to occur in July, which is 7 months after the start of the year. Based on that information, if we had to organize this information in the form of a point that we're going to be graphing here in a second, what would that point be? Our x value is time, and so 7 months into this cycle, the temperature is going to be 102 degrees. So your point is 7, 102. All right, the last sentence says its coldest temperatures. That's going to be our min. Again, that's another extreme. You can't get colder than the coldest. Our minimum temperature is going to be 28 degrees. But it doesn't tell us what time of year that's happening at. And so this x value for this point is unknown to us right now. But that's no problem. We can still graph this. All right, here's our graph. You can see I plotted the point, 7, 102. I'm not sure what x value my minimum is going to be at, but I know its y value is 28. And so I just put this dot here. I went ahead and said, you know what? They told us what the period is. It's 12 months. And so in 12 months, 7 plus 12, 19, we're going to have another max. My next step here is just going to be to complete these dots, connect them. And to me, that looks like a cosine graph. And so step one of our process was to annotate our problem, get our given information. Step two was to graph it, which we've just done. And based on what we see in our graph, we decide that we are going to use a cosine function to model this information. So I've written my cosine function out with space to fill in some blanks. Let's plug in the information that's really easy for us to figure out. For one thing, we see that our initial point here is at 7. Normally, we would have our initial point for our cosine function on the y-axis. And so we see that there's been a phase shift to the right 7. What that's going to look like here is just an x minus 7 for our phase shift. The other information that I think is going to be easy for us to work with is this 12-month period. We know that in order to find this b value, we need to use our period. We're not directly plugging our period in. We're not plugging 12 in for this b value. In order to find our b value, we're taking our period and we're setting it equal to 2 pi over b so that b becomes 2 pi over 12, right? You can cross multiply, do some algebra, and you'll get b is equal to 2 pi over your period, which is 12. And so that's what I'm going to plug in here. Again, we like exact values. And if we plug that into our calculator, we're going to get some weird decimal that we don't want to have to deal with. Now, all we are left with is our amplitude and our midline. And that's what I want your guys' help with. So right now, tell me what the midline is and tell me what the amplitude of this function is. All right, PCH, you should have come up with your midline being y equals 65 and your amplitude being 37. How I found my midline, in case you didn't come up with that, was if I take an average of my max and my min, that's going to give me my midline. And so I plug in those numbers, find the average, and I get 65. If you want to double check, the distance between 65 and our maximum is 37. The distance between 65 and 28 is 37. But that's what the average is. It's the middle of two numbers. And so that's what I use to find my midline. So I'm going to add 65 to the end of my function here. And lastly, of course, like I was just talking about, the amplitude is the distance between your midline and your minimum, or your midline and your maximum. I decided to do my midline minus my minimum to get me 37, which of course is my amplitude. The last thing I'll check is it looks like my cosine function is right side up, so this is going to be a positive 37. All right, nice work, BCH.